Good morning. This is Dr. Jana from CS Department of Business Engineering College. Today's video lecture will be covering convolutional neural network, which is one of the important topic for computer science and engineering students, and especially for the candidates or for the readers who will be dealing with deep learning. Okay, as you know that the machine learning, which is a subset of artificial intelligence, and when the machine learning uses purely neural network, concept of neural network or artificial neural network, we can in general call it as the convolutional neural network. Okay, so today in this video lecture we'll be focusing on this convolutional neural network, and as you know that this convolutional neural network is a deep learning algorithm. There are several algorithms for machine learning, for deep learning. This deep learning, one of the important algorithms is the convolutional neural network. So many people they confuse what is the deep learning, what is that depth or deep here. See, if you minutely observe the multi-layer perceptron or multi-layer artificial neural network, both are same. So we find that one input layer, if you check it here, this is the input layer of this multi-layer perceptron, this is hidden layer, and this is the output layer. Okay, so this we call as a typical neural network, and convolutional network also the same. There is no much difference. There are also some input layers, there is some output layer, and some hidden layer. At least one hidden layer is there. But now we are seeing the difference between the machine learning perceptron, the multi-layer perceptron, and the deep learning. See, multi-layer perceptron, even if you say many number of hidden layers are there, they are confined to 3 or 4. We never go beyond 4 number of layers, hidden layers. Why the reason is that if you see this multi-layer perceptron, the concept is that each neuron in each layer, say this is the input layer, in input layer we are having 1, 2, 3 neurons. So this neuron is immediately connected to all the neurons in the hidden layer. Similarly, the second neuron is also totally connected to all the neurons in the hidden layer. Suppose there are n number of neurons in input layer, similarly there are n number of layers in hidden layer. So all the n number of neurons in the input layer are connected individually to all the n number of your neurons in the hidden layer. And you have some idea about the training of this multi-layer perceptron. I already given a video, that is the backpropagation training, where we using multi-layer perceptron. So here what we do, the training part, the two part is there, one is the forward pass, second one is the backward pass. In the backward pass of this our backpropagation training, it is purely the learning, that is the training, or what we say the weight adjustment. Imagine if this much of neurons are connected, and all this connection it is labeled with a weight, because whenever there is a connection from one neuron to another neuron, so it has some input and it must be associated with some weight. Suppose n plus 1 number of weights are there for one neuron. Similarly, n number of neurons, you can imagine how many numbers. I can say an example, if it is 224 by 224 images of color images, there will be around 1.5 lakhs of pixels. So all these pixels, they are represented by some weights there. So this much of weight have to be adjusted. You can understand it is very cumbersome and all things. And we restricted the number of layers to 3 or 4 maximum according to our requirement. But in case of deep learning, the number of hidden layers, it can go up to 100. Sometimes it can go beyond that one. Then what is the meaning of putting so many number of layers? See, our thing is that I want to have more number of features. So for example, I am going for image recognition, say face recognitions. In general, I can say face recognition. The face recognitions, what we see, whatever the image you see, the image as a face, it is consisting a number of pixels. Okay, so enter the face, the nose, the eye, the mouth, the teeth, the hair, whatever things you are having on your face, they all are represented by the pixels only. Pixel means the picture elements. Okay, so these pixels, they contain some values, or we call it as the uh, brightness value, or brightness function, or brightness value. Okay, now in the first layer, we try to find out what are the edges, what are the blurs, what are the things are there, the demarcation, etc. All the things we can find out. The second layer, we can go for finding the nose, the eye, the ear, the teeth, face, and all things we want to get it there. Similarly, in the layer number 3, we can go for the various shapes, because you see a person when we are going for training and we can have a number of photographs, it is not necessary that the person will be imposing just like the same thing what is imposing there the first time. So he may have different shapes, he may have different postures, he may have different, so all the things it will be difficult for the machine to understand. So for that, what we do, at least for one picture, at least we take some 50 to 100 number of pictures, different pose, different texture, different all things, black and white or gray, all things we take it there. So when you train these things to the machine using the deep learning or whatever things are there, then you can understand the number of layers it increases whenever you go for more number of features. So as we are using more number of layers, or we are going in depth, or we are adding more number of layers here, that is the reason we call it as the deep learning. Clear? So this is the concept I have given you. What is the multi-layer perceptron and what is the deep learning? It's clear? Now we come to our convolutional neural network. Why? Because already multi-layer perceptron is there. Why should we go for this convolutional neural network? Okay. So let us see what are the limitations of this multi-layer perceptron and how we can overcome, and why we are going for this convolutional neural network. The first point we see in our convolutional neural, in our typical neural network, whatever the diagram I am showing it here, it is a typical neural network. It is an example of multi-layer perceptron. Here you see the neurons, this neuron which is given in blue color from the input layer, and this is the neurons in blue color in the hidden layer. So this neuron is connected to all the neurons, you can see one. Similarly, while we are coming to the second neuron on the input layer, that also again it will be connected to all the neurons in the hidden layer. Like that, how many neurons are there in this input layer? All are connected, totally connected to the neurons in the hidden layer. Similarly, suppose there are more number of hidden layers. So here, how many neurons? They will be connected with the neurons of the second hidden layers, totally connected individually. Now you can understand, whenever we go for, because in the multi-layer perceptron training means weight adjustment, initially we take some weight, say we take 0.15, 0.20, 0.25, 0.30, 0.35. This weight we can select from 0 to 1. Okay, randomly we can select. Because there is a hand rule. You cannot select high values like 0.8, 0.9. What happened? Already those things are covered in the fundamental. There will be a network paralysis and there will be some local minima. So we cannot use. So initially, what we do, we take some lesser values like 0.15, 0.20, 0.25, 0.1, we take it there, and we go on adjustment. That what I explained in the backpropagation training algorithm. And finally, when we find the target output is equal to the expected output, then we can stop the training and the model is ready, and it can be applied to any type of classification problems. Unit it can take for classification as well as regression, but we, as I told you, are mainly focusing on this classification. So when the model is ready, neural model is ready, then we can apply for these things. Now this is the thing. It has one of the drawbacks, as all individual neurons are totally connected and whenever there is a connection, a weight is associated with that one. So this weight adjustment means number of weights. I told you that for a 224 by 224 color image, we have to go for some lakhs of weight adjustment, which is very cumbersome and it is time consuming and all the things. Also, you need more CPU on that. Now, in case of convolutional network, if you see it here, this is the input of this convolutional network. It is not one layer; it is a group of layers like that. So now, instead of providing individual neurons here, a region of neurons, this is the region of 4 neurons, they are mapped to one here. You got it now? Then we can say how it is mapped. Yeah, this mapping is done using some kernel, what we call it as the convolutional neural network kernel. So that means we take a kernel, say I can take 3 by 3, I can take 5 by 5, say suppose I am going for detecting the average, or I am going for detecting the edges, etc., or I am going to detect. So there are different things there. So for that we have different kernels. So these kernels we take, these kernels will be operated on the entire input. Here the neurons are the input here. That means in rows from this to this, again from this to this, this to this. The entire images which is represented by array of pixels or array of neurons. So your kernel will be operated on all things. Suppose it is a 3 by 3, the first 3 by 3 will be operated here, the second 3 by 3, again it will be operated. That means it is purely based on the convolution. We take some kernels and this kernel is convoluted with the entire image. So as the network depends purely on the convolution with the convolutional network kernel, so we call it as a convolutional neural network. Is it clear? So second point what we are discussing, instead of individually connecting to all the neurons in the hidden layer, a region of neuron, you see it here, these are only mapped to one. Similarly, the next 4 is mapped to the second one. The bottom left hand side, this 4 is mapped to this one, and the bottom right side, this 4 is mapped to this one. How the mapping is done, I told you that we are using some convolutional neural network kernel or the filter, we can say the name is also filter. So once it is convoluted with that one, convolution is very simple. So there is a mathematical equation for that one, but you remember, suppose a 3 by 3 there, so individually this 3 by 3 will be operated on the kernel. So the first element will be multiplied with the first one, the second element will be multiplied with the second one, third element. So like that we can go on to it, and whatever things finally it comes, that we can find it. Okay. So now we have taken a region, a small region of this input neuron, and that we have mapped here. Then what is the purpose of all this? Why we are doing all this? See, for 4 neurons here, I represented by 1. This is the reduction in dimensionality. So similarly, for the remaining 4 here in the top layer, that is represented by this thing. Okay. So this is one of the advantages of convolutional neural network. And finally, you can see here these 4 neurons. So this is one output because 1, 2, 3, 4 it is coming here. This is the input with some weights, and these 1, 2, 3, 4 it is also coming here. Okay. So we can get it like this. So this region, what we are mapping to one neuron in the hidden layer, this region we call it as the local receptive fields. What we call it as? Local receptive fields. So in the convolutional neural network, 3 things are important. First one is the local receptive fields. Second one is the shared weights and biases. And third one is the activation and pulling. Okay, these things will study in the details. Now we are going for the second point. The second point, what is most important for us, that I will tell to you. We are discussing here. The second thing is that here the weights and biases. Biases, of course, it is constant. We don't change the biases. Once it is once it is selected, it remains. But the weights in the training, it continuously changes. But we don't do the same thing in the convolutional neural network. Here, the weights and the biases are fixed throughout the network. Okay, then what happens? So this makes the network to that is the tolerance to translations of object or image object in the images. For example, suppose I am using a backpropagation, or I am using one multilayer perceptron. My purpose is that I want to identify an object. Say the object is a rose flower which is appearing at the top left hand side. Say for example, top left hand side is here. Say for example, okay, here a rose flower is appearing, but I want to put the same rose flower here. You can check it here. So now, if I am using this multilayer perceptron using the backpropagation and all things, so it will train the network in such a way that first we will try to trace that rose flower on the left hand side top. That means if it is translated, it is shifted to some other places, it gets confusion. So this translation property, it is also taken care by the convolutional neural network. You get it now? Now, the first thing what I will tell you that one is the local receptive field, second one is the shared weights and biases. Okay. So what we do, the entire thing we implement using this convolution, because I take a kernel or a filter. This filter is convoluted with the entire image. Here images means the array of pixels. Okay. So because the entire thing is done effectively or efficiently by using convolution, that is the reason why we call that the convolutional neural network. The second point I told you that it is the weights and biases. The weight and biases for the traditional neural network, it goes on changing as we go for updation of all things. But in CNN, weight and biases remains same for all the hidden layers, for all the to detect all the features or all things. Okay. Now this has led to the network tolerance. That means suppose I told you that rose flower is in the top left and I shifted into the bottom right, so it should be able to detect, because the rose is there, rose is the object and the entire image screen is there, the frame is there, it is somewhere. It is not necessary all the time the rose will be at the left hand side top, it can be any part and any place of the frame. So the network should be able to identify. The thing is that if the object is there, then it should be identified irrespective of the location and all things. That is taken care by the convolutional neural network. Okay. So then for this what we do, the neural network tend to detect the object. So wherever it is present in the image, that is the advantages of this convolutional neural network over the traditional or the typical neural network. Second thing, we are going for the active pooling. Okay, so that I will discuss. What we do in this pooling? See, whenever I have taken a kernel or a filter and I have convoluted with some slice, one slice of that input, and I find some feature map. Suppose the feature map is coming just like this. This is one of the feature maps. After convolution, it is coming all the things. In the pooling, what we do, we use some network like ReLU, R-E-L-U. Using this ReLU, it converts all the negative into 0, map all the negative value to 0, and the positive value remains as it is. So if you can say, suppose it is coming -1, 3, 8, -4, I like that by -2, 9, something 6 and 5. So it is coming. So all the minus, so -1, -4, they are converted to 0, and -2 is converted to 0, -7 and -5 they are also converted to 0, and this -7 it is converted to 0. So this is the first part. What it does, all the negative values is mapped to 0 and all the positive value remains as it is. Then what I do, I go for the pooling. There are different type of pooling here, but we will be focusing on this max pooling. The max pooling, what we do, suppose after this ReLU network, it finds these are things, we find a small region here for 2 by 2 where it is green. So you see 0, 3, 0, 9. What is the max value here? Max value is 9. So what I do, the entire thing, it is mapped into 9 only here. Similarly, out of this, the maximum value is 8, so it is mapped to 8 here. Similarly, out of this, the maximum is 4, it is mapped to here. Then out of this, maximum is 8, it is mapped to here. Then what is the purpose of all the things? So this helps us in reducing the dimensionality. So that is the thing what happens in our convolutional neural network. Now you can clearly understand the reduced dimensionality. We are not bothered about the entire thing. We are only worried about these things. You get it now? So now, suppose there are 1.5 lakh of neurons are there, some weights are there, I have to go on training. I am not going to train all those things. I am only worried about all things. Here, so this is the concept of convolutional neural network. I hope the fundamental things you got it there. Then we go into details for this convolutional. What is the main objective in our convolutional neural network? That we need a system that can do this feature learning, or that can extract this feature learning, or this feature learning sometimes we call it the representation learning. Okay, the feature learning or the representation learning. So these so previously we are doing it manually, but now I want the system to do automatically. Okay, now there are several techniques for this. Previously we are using unsupervised like K-mean and principal component analysis PCA. Then under the supervised we are using supervised dictionary learning or the neural net wherever it is. But so these are overcome by the convolutional neural network. Now you can see a traditional neural network where the input layer 1, 2, 3, 4 and one output layer, one hidden layer, and the green neuron, if you see it here, that is the first neuron in this input layer. They are connected to all the blue neurons and all connections are there, and all the connections are also associated with a weight. Okay, you get it now? So this is one hidden layer. Suppose there are 3 or 4 hidden layers in between, and suppose there are more number of neurons in each layer. You can imagine what a tedious job, and how many times we have to update, and how many times we have to represent all these weights. Okay, that is the drawback here. Okay, here you see this example. Suppose another common problem in the multi-layer perceptron that it reacts differently to an input image and its shifted version. What I told you that rows in the left hand side top or in the right hand side bottom. So this is shifted. So the traditional neural network it reacts differently, but the convolutional neural network, the positive thing is that it is there in the left hand side or the middle, the bottom. It effectively recognition and classification data. Okay. Then clearly the MLP are not the best idea to use for image processing. One of the main problem is that the spatial information is lost when the image is patterned into the multi-layer perceptron. Okay, so this is the thing, that is the reason why we are going for this convolutional neural network. Then what we do actually, I told you that we are using some filter, or we say we are using some kernels. So suppose this is the source pixel, that is the image is converted to some pixels. The source pixel is represented by an array of numbers 3, 0, 1, or numbers are there. And I am using a kernel, or what you say, I am using a convolution filter. You can say filter, convolution filter, or you can say kernel. So this is convoluted with the first 3 by 3, then the second 3 by 3, like that it is going. And if you see here, the center it is 6, and after convolution, so what is mean by convolution? You see 3 into minus 1, or minus 1 into 3, then plus 0 into 0, plus 1 into 1. So whatever it is coming, that is there, plus, okay, then 2 into minus 2, then the 6 into 0. So all the things it is worked out here, you can see it here. And if you simplify all the things, it is coming a whole number. It is coming minus 3, minus 2, minus 4, or plus 2, plus something it is coming. Okay, so that means the entire 3 by 3 is represented by this one here. So this is the source pixel, and this is the destination pixel. So a 3 by 3, that means 9 pixels are represented by only one here. Get it now? Now we worry how the different features are learned by the network, and whether it is possible that the network will learn the same features having say 10 nodes or something like that. See, I give some example here how these filters are selected. Suppose I am going for edge detection. Suppose this is some anomaly there. So because the image is very small one, you can enlarge it in your system, and you can see the edges are clearly defined using this edge detection. So what we do it here in the edge detection, that is you have to select this filter like a 3 by 3 or 5 by, because we have to put this center position right from the top left, and we go on shifting. Then you go to the second line, they go to the third line until the last bottom corner this point. Okay. So how we do? Then we take the entire image and we go for the convolution of this filter with that one, and finally I find. So for this edge detection, the center is +8 because it is 0 to 8, 9, 3, 3, 9 are there. So all the surrounding are -1. So this is one of the filter, it is already done. So if you apply this thing on any image, the edges of the image will be clearly demarcated. Similarly, suppose I want for sharpness. Here sharpness, what I have done is just minutely observe this filter and this filter. Here the surrounding all the pixels were -1, but here only this one, this one, this one, and this one is -1, and at the corner 4 are 0, and middle I am putting it 5. Right. So if you go for convolution of this filter on this image, then you can find the sharpness of that picture. Because it is small, you are unable to do it. But if you compare all these two pictures, you get more sharpness here. The teeth of this animal you can clearly see in a large picture. Here it is little because the small one you are able to. So after this filter, so we have done this filtering. After the filter have passed over the image, then a feature map is generated. Okay. So how many filters are there? For them a feature map is generated. So like that we can have a number of feature maps, and all these feature maps we can block it and put it there in one. Okay. So this is the thing. Then you see it here. This is the input image I am giving it here, and I am going for the convolution using this ReLU, and then I am going for the pooling. Pooling, I told you that it is the reduction of dimensionality. It is mapping and taking the converting the negative to 0 and replacing with the maximum for the entire block. So this is pooling. Again I am going for the convolution layer 2 and plus ReLU and pooling. So what is this convolution layer 1, 2, 3, 4 like that I am giving you? See, I told that initially I am going for detecting the edges or the block. So for that we have to use the first one, the filter what I have given. Suppose I want to go for the sharpness, then you have to use the convolution filter second one. Suppose I want to go for the shapes, all the things, I have to use another filter. So how to select that filter and what is the different, that is a different aspect, that is a different topic. Those things you can refer in signal processing, and you will have clarity and a clear idea about how to go for averaging, that is for smoothness. Suppose we take an image, we add some salt-pepper noise. Salt-pepper means the white and black dots, we add it there. Intentionally we add it there. After adding, I want to remove. How do you remove all the things? I cannot remove it by simply by checking or by cleaning with a cotton and all things. What I have to do? I have to go for averaging. Averaging means what? See, I put a dot here. Suppose this is a dot here, and here it is white, here it is white. What I do? This white plus white divided by 2, and what the average? This point I am going to replace by that average. See, surrounding is white and middle is there is one black. Automatically it is eliminated. It is also replaced by white one. Suppose surrounding is black and middle is white. By taking the average also it is done. So like that it is the averaging. But one of the drawbacks in this averaging is that all the important features are lost. That means the sharpness, the edges, the lines, all these important properties, because these are represented by high frequency values. Okay, and whenever you are going for averaging, all the high frequency values are lost. That's why we find some problem while we are going for averaging. But this one effect is there, we call it de-blurring, or we go to call it the blurring. Some hazy-like or smoky-like things it appears there. Some of the other drawbacks that the MLP, that it don't scale well for images. That is point number 1. It ignores the information brought by pixels, positions and correlations with the neighbors. That is the third one. Second one, and it cannot handle translation. Translation shifting from, suppose it is there in the left hand side corner and you have to put in the right hand side bottom. So this translation problem is there. Then the general idea in CNN, the pixel position and neighborhood have a semantic meanings. That means suppose something happens here, then the immediate neighbor can tell what has happened. These people cannot say. That is the meaning. That means all the information can have in the immediate neurons. The same thing we are doing. The pixel positions and neighborhood have semantic meanings, and elements of interest can appear anywhere in the image. That is the thing we do. We also see here a comparison in the multi-layer perceptor and CNN. CNN MLP, I told you, one layer, input layer, two hidden layers, and output layer. So all the neurons are connected. Here it is not like the input is given just like a three-dimensional solid here, and all these hidden layers they are also put just like these things. If you remember, after convoluting with the filters, we get some picture maps. The entire picture maps are provided here, just like a 3D things is there, and it will be operating on this entire thing. And we are not going to change the weights. That means there is no weight operation here, and I am not going to change the bias here. Okay. Then what I do? Suppose I go for this picture map. This picture map we cannot operate all at a time. I take one slice of that one. So this one slice, what I have taken it here, you see, this is a slice. Okay. This slice will be operated on the input. Input also like that. A bunch of things we have taken. We have taken one slice of this input and operating on one slice of this picture map. This slice we call it as the kernel. And this filter introduce the translation in there. So it is translation invariant. That means suppose the image is shifted to some other places, there is no difference. It will be able to classify and it will be able to detect. Okay. Then something you can go for. A good question comes. What about the top, left, right, bottom, left and right? Because say suppose this is the image. This is the image and this is the first pixel. Then because I am starting here, then it will appear here. Because it is 3 by 3, the first it will come here. To get that one, what I do? I go for some padding. Padding means I'm adding something here. I added two layers here. I have given some random values, 0, whatever things are there. And while I am going to operating, so there are two type of things are there. You call it the full padding, and here you call the same padding. Same padding means how many neurons are here, how many pixels are there. Same pixel it is coming here. You see, it is a 5 by 5. Here also it is coming 5 by 5. But initially it is 5 by 5. It is coming 1, 2, 3, 4, 5, 7 by 7. So this we call it the full padding. This we call it the same padding. So you can say if full padding we get so many features, then we can go for full padding. No, always it does not give a good result, because sometimes it goes for confusion, because you add so many features, you get confusion. So once it is confused, it becomes overfitting. That is a concept already I covered in some videos that you can go. And if you take less than certain, you could face the problem of less fitting, overfitting or less fitting. Okay. But there is some other things we call it the best fitting. So we always try for the best fitting. Okay. So padding, it is essentially make the feature maps produced by the filter kernels the same size as the original. So for that, what you need to do? You need to go for this same padding. Same padding, what I have done? I have padded only one layer surrounding to the pixels. This layer, this column, this column. Okay. Now, if you go for a 3 by 3 filter and operate on all things, what is the initially things are there? The same thing also will output. Okay. Then introduction to the ReLU, because I told you that this is a non-linearity, that it introduced the non-linearity. ReLU, the definition you know is the rectified non-linear unit. Rectified linear unit, but is non-linear unit. So here the main purpose is that it introduced the non-linearity, and the vanishing gradient problem occurring in the sigmoid function also, that is also taken care here. So that is the reason the network readily available, that is ReLU. We frequently using this ReLU. Okay. Now there are 3 layers in the convolutional neural network. The first layer is the convolutional layer, second one is the pooling layer, third one is the fully connected layer. Okay. There are 3 types of layers in a convolutional neural network. First one is the convolutional layer, called convolutional layer. Second one is the pooling layer, and third one is the fully connected layer. And each of these layers, they have different parameters and they have different tasks and different duties. So suppose I go for the convolutional layer. Here the main thing is that we are going for convolution with some filters. So this is the most important parameters are the number of kernels and the size of the kernels. Pooling layers are similar to the convolutional layers, but they perform specific functions such as max pooling, because there are so many things, as I told that we will be going for max. So you remember all things. So I have taken after this convolution I got -8 plus 7 6 like that. All this negative I converted to 0, and out of 4 the what is the maximum one that I have pulled, I mapped to another one. If you remember that one initially the pictures I have shown you, it is there. So then that is the job which is done in the pooling layer, and finally we go for the fully connected layer. These are placed before the classification output of the CNN and are used to pattern the results before classification. This is similar to the output layer of MLP. See, MLP we are not getting just like a array of matrix. You are getting just like now a pattern, just a vertical one, are getting all the outputs. The same job is done here by the fully connected things. Okay. Then what do the CNN layers learn? Suppose there are increasing complexity where the MLP fails, then CNN can give a solution. The first layer learn basic features detections, basic feature detection like the edges, the corners, etc. The middle layer learn filters like the eyes, nose, etc. The last layer have a higher representation. They learn to recognize the full objects in different say shapes and positions. Okay, one is the shape, one is the positions. All the things will be taken care by that. So these are the things it is done using in our convolutional neural network. I hope I have given you the minimum stuff and some idea how the convolutional neural network work and how these things happen inside these things. Now, if you want the implementations of all the things, there are two options for you. We can implement all the things using the MATLAB. For that, you have to register under this MathWorks online, and you can see some videos there. Otherwise, you can use the open source like Python using some packages there. You can also implement. Maybe in our next video, I will try to give a hands-on how to implement this convolutional neural network. But remember one thing, even if it is not the part of this NN syllabus, but it is part and parcel of that one, because when you are going for any deep learning related things, without convolutional neural network, deep learning is impossible. So they who do not know CNN, they do not know deep learning at all. Okay. So now you can understand the importance of this topic and all this lesson. And before stepping your foot into deep learning, you must and mandatorily you have to understand what is CNN and what is all things, then you have to go for that. So I wish you all the best for your exams. Take care of your health and stay in your house and study well, help your parents. Okay, so maintain some social distances. Thank you all for listening my video lectures. I'll be happy if any comments or any improvement and suggestions is given in my email. This I'll be uploading in our YouTube, and link will be given to our binder app, that is the LMS learning management system, whatever things are there. So you please go through all the things, and I'll be happy if you feel free to send a comments or feedback on that one. Thank you. Till then, goodbye.